Okay, so let's go ahead and take a look at those extra practice. I thought I had a video already, but I did not. So I'm going to go ahead and let's just kind of see how that works out. So hopefully this is going to work out okay. So this is my extra practice. I wanted to look at the cosine of negative 13 pi over 12 to start us out. So there's a couple of options. One of those options would be to look at that problem through the lens of a sum and difference. So there's many ways that I could look at this. So I decided I would go with 10 twelfths and 3 twelfths. And although we've done this problem in class a few times, and a lot of people like 9 and 4, but I actually picked 10 and 3. So 10 twelfths and 5 twelfths reduce very nicely to 5 pi over 6 and pi over 4, which are values that we know. Now you'll also notice that this says the cosine of negative 13 twelfths, and I did the cosine of positive 13 twelfths. Because the cosine is an even function, that means I can throw that negative away and not worry about it. So since I picked alpha and beta in a way that I add together, I wrote down my identity for the cosine of alpha plus beta, where I chose alpha to be 5 pi over 6 and beta to be pi over 4. So I kind of just threw those numbers in. And then using just some quick little pieces from our unit circle, I know that the cosine of any kind of pi over 6 is root 3 over 2. The sine of any kind of pi over 6 is 1/2, and I made them positives and negatives based on the quadrant that they are in. Remember, the cosine is negative in the second quadrant, but the sine was positive. Remember ASTC. And of course, the sine and cosine of pi over 4 are plain old root 2 over 2, and we're done. Now, you'll notice this is option 1. Because pi over 12 could be done using a sum or difference, or it could be done with a half angle. So option number 2 is we could consider us looking at 13 twelfths as 13 pi over 6 cut in half. So again, writing my identity. Notice this is a little tricky because negative 13 twelfths is actually sitting in the second quadrant, and I know that the cosine in that second quadrant would be negative. And of course, if I made it a positive, it actually ultimately puts it in the third quadrant, which is why it says Q3, because rotating forward 13 twelfths is in the third quadrant. And then I was able to just kind of go through the process. Now, 13 pi over 6 is the angle that got cut in half, which is actually quadrant 1. This is always very confusing with all those quadrant pieces. We have to be very careful. And we know that the cosine of any kind of pi over 6 is root 3 over 2. And it was positive because it's in the first quadrant. Quick multiply by 2 cleans that up just a little teeny bit further, but of course we know that the square root of 4 is 2, and that leaves us our final answer down here. I personally think option 1 was probably the easier of the two. Now, for problem number 2, we were looking at the sine of 7 pi over 8. Now, this one does not have those two options. You pretty much have to go with a half angle identity. So I decided to take 7 pi over 4 and cut it in half. So I wrote down my identity. Now I happen to know that 7 pi over 8 is in the second quadrant, and I know that the sine is positive in the second quadrant. So I'm going to pick the positive of these two. Notice I highlighted the positive. But when I consider 7 pi over 8 as 7 pi over 4 cut in half, 7 pi over 4 itself is in the fourth quadrant. And I know that the cosine in the fourth quadrant is negative. Now you want to notice that even though it is a half angle sine, I'm using an identity that has a cosine in it because that's the identity that we have. The things that we've been using, if you look up your identity, the half angle for the sine and the cosine both refer to a cosine, which is kind of interesting. So I'm just going to plug in the root 2 over 2, and just like the last problem, if we multiply the top and bottom by 2, notice 2 times 1 is 2, the 2's cancel, and I get all of that over 4, but the square root of 4 is 2. And this problem really only has one viable solution for that. Now, problem 3, I know a lot of people get a little bit bugged by problem 3, because problem 3 says, let's find that tangent of beta, but let's not bother to use a triangle. And I understand why a lot of people would look at it and go, why the heck wouldn't I use a triangle? So what I did is one option was I said, okay, fine. Let's say 1 plus the cotangent is the cosecant squared. Now, that may strike you a little bit odd, but there's a reason why. Because if I know what the sine is, the cosecant is simply its reciprocal. So I can do just a little bit of arithmetic here and isolate the cotangent squared. And that means to find the tangent, I would simply need to finish that up and flip it over. And so the tangent itself would be the square root of that. And again, I would actually be okay if you wrote it as 5 over root 56, but if you simplified it a little bit better, that would be fine. So notice it says option 1, because option 2 was that I could have looked at it as sine squared plus cosine squared is 1. And since I told you the sine was 5 over 9, I squared it, moved it to the other side, took a square root. And then, of course, if I know the sine and the cosine, all I have to do is divide the sine by the cosine, and that will give me my tangent. So I took the sine and the cosine, and I divided them. And I got exactly the same answer as I got previously. But like I said, it would have been okay if you left it as 5 over root 56. Now, problem number 4 is a little bit of a tricky little question because it says the secant of pi over 2 minus beta. That's kind of ugly. But you have to know that that is a cosecant. So the first thing I would do is I would just use the fact that that's a cofunction and say that that's a cosecant. And again, if I'm looking for the cotangent and I know the cosecant, all I would have to do is plug in the cosecant for here and look for the cotangent. So a little bit of arithmetic, I'm going to subtract 1 for both sides and take a square root. And notice because we took the square root of both sides, we do get that plus or minus. And that ends problem number 4. Okay, so that's our first chunk of that review. Okay, so moving on to question number 5. Let me move this out of the way. So question number 5 is when we're being asked to solve. So the first thing that I personally like to do when asked to solve a problem is if I see a question like this, I would look up the identity that involves a cosine. And if you look at our list, we had one identity that was 2 cosine squareds minus 1. So notice that I have these things set equal. If I subtracted the cosine to the other side, notice these ones would cancel. Well, in this case, you'll notice that both of these things have a cosine in common. And that cosine that we have in common then allows me to factor a cosine out. And then I'm allowed to use the zero product property. So the only way that this product that can be 0 is if the blue piece is 0 or if the orange piece is 0. So if blue is 0 or the orange piece is 0, I'm looking for when is the unit circle telling me that the cosine is 0 or 1/2. And those things happen at pi over 2 and 3 pi over 2. Remember, those are quadrantal, where the cosine is 0 is where the x value is 0, which would be straight up and straight down, or the cosine is 1/2 in the first quadrant and the fourth quadrant. It's both pi over 3s as reference angles. Now for question 6, similarly, we have this little story right here. But one thing I don't like about it is the left side refers to a sine, whereas the right side refers to a cosine. So the first thing I did is I used our Pythagorean identity that sine squared plus cosine squared is 1, and I replaced cosine squared with 1 minus sine squared. So a little bit of moving things around, that allows me to isolate things. And we've actually seen this very same factor showed up, that if I factor it, I could make my first parentheses set with a 2 sign and a 1 sign, and the other part would be a couple of 1s. So this factors very nicely as follows, because you'll notice that this product right here is 2 sine squared. This product is negative 2 sine. This product is positive sine, which adds up to that. And then the last product is negative 1. And so I want the sine to be negative 1/2 or the sine to be positive 1. And then we're looking for angles that are pi over 6s, but in the third and fourth quadrant where the sine is negative, or when is the y value 1, which happens at pi over 2, and the pi over 6s that exist in the third and the fourth quadrant. And that kind of finishes up problems 5 through 6. And I think that'll be it for this first video.